right, we are going to graph a rational function, and we're going to have the same degree in the numerator as we do in the denominator. So we're going to work through a list of important things to help us determine what this picture is going to look like. So for our domain, we need to figure out what value is going to make our denominator 0. So go ahead, take your denominator. This one, it's not super obvious what's going to make 0. So let's set it equal to 0. And then we solve this equation for x. So let's add 5 to both sides. And then let's divide both sides by 3. So when x equals 5/3, that means our denominator is 0, and we can't have that. So when we write out what our domain is, we need to do everything but 5/3. And we're going to do interval notation for our domain. So -infinity to 5/3, union 5/3 to infinity. So there's our domain. Next up, let's identify our vertical asymptotes. Now, you've already done all the work to figure out what value makes 0 in the domain, or in the denominator. So your vertical asymptote is going to be that same value. So your vertical asymptote is going to be x equals 5/3. Next, let's identify whether we're going to have horizontal or oblique asymptotes. So take a look. We want to compare the degree in the numerator to the degree in the denominator. We have a linear numerator and we have a linear denominator. So we can take the ratio of the coefficients of our lead term. So we have a 4 up top and a 3 on bottom. So that means our horizontal asymptote here is going to be the line y equals 4/3. Next, let's check for holes. When we look for holes, we want to factor both the numerator and the denominator. Since I have linear terms for both my numerator and denominator, there's no greatest common factor between the two, so there's no additional factoring that I can do. So these are different terms on top and bottom, so that just means there's no holes in the graph. Next up, let's check for x-intercepts. So to find an x-intercept, go ahead and plug in y equals 0. And let's see what we get. This looks pretty ugly to solve. The first thing I would do would be to multiply both sides by the denominator. So notice on the right, 3x minus 5, and the numerator and the denominator, both of those terms cancel. On the left-hand side, 0 times this quantity 3x minus 5 still just gives me 0. So I'm left with 0 equals 4x plus 3, which is much, much nicer to solve. So let's move the 3 over, and then let's divide by 4. So my x-intercept is at -3/4. Notice I could have just taken the numerator and set that equal to 0. That'll work every single time when you're finding x-intercepts. Lastly, let's find y-intercepts. So for the y-intercept, we can go ahead and take every x value and plug in 0. Four times 0 plus 3 is 3. 3 times 0 minus 5 is -5. So we have a y-intercept at -3/5. Let's write both of our intercepts as points. So that would be the point 0, -3/5, and then our x-intercept would be the point -3/4, 0. We have enough information here to at least get started on our graph. So to the side, I'm going to go ahead and sketch in some axes. Start with your asymptotes. So at 5/3, so that's between 1 and 2, a little bit closer to 2. I'm going to sketch in my dashed line right here. This is not part of my graph. It's just a boundary, so x equals 5/3. And then my horizontal asymptote is at 4/3. So that's between 1 and 2. Closer to 1, we can sketch in that asymptote. And I'll go ahead and label that graph. So y equals 4/3. And then let's plot our points for our intercept. So -3/4 for an x-intercept is about there. And our y-intercept of -3/5 is about there. And I think I have a pretty good idea of what this picture is going to look like. I know it has to go through those two intercepts. I know it's not going to cross this vertical asymptote. And so I'm thinking it's probably going to hang out and kind of make a curve right here. If you want, as fancy as we're going to get with our graphing here, we can go ahead and plug in this function just to kind of verify. You can always plug in additional points. So yep, as I suspected on this left-hand side, it's going to follow below the horizontal asymptote and be to the left of the vertical asymptote. And then it's kind of got its mirror image in the opposite quadrant there. So let's go ahead and plug this in. There's that piece. And then I can sketch in this piece right here. And so there's my rational function.